All right. We're going to look at a little slowdown here, nice relaxed section talking about angles of triangles, classifying triangles, and those types of things. So let's go ahead and look at classifying a triangle by its sides. Okay, and if I classify it by its sides, there's going to be three types. There's the scalene triangle, where all, oh yikes, that's yuck, where all sides are different lengths. Quick example of a scalene would be something like this. Okay, scalene triangle, all of those are different lengths. Then we would have the isosceles triangle. The isosceles triangle at least two sides are congruent. Isosceles, at least two sides are congruent. And so that would be a good example of an isosceles triangle as long as those are marked. And then finally, we're going to have an equilateral triangle. Okay, equilateral is all three sides are congruent. And so in this case, that would be an equilateral triangle. However, that triangle is also isosceles, because isosceles just needs at least two congruent sides. So an equilateral triangle is isosceles as well. So now let's look at classifying these triangles by their angles. And our first, we're going to start with the smallest, and that's the acute. The acute triangle has three acute angles. And so I could use that triangle right there. All three of those angles would be less than 90 degrees, so that makes it an acute triangle. My next one is going to be an obtuse triangle, and that's going to have one obtuse angle. Remember that obtuse angle is greater than 90, but less than 180. So let's see if they give me, yeah, there's an obtuse. So there's an obtuse triangle. This angle right here is greater than 90 degrees. Okay, we've got two more. Our next one is going to be the right triangle. And in the right triangle, it's going to have one right angle. And so that would be an example of a right triangle. It has one right angle. And then finally, our last one kind of gets forgotten sometimes. So we have the equiangular. And in the equiangular triangle, all three angles are congruent, which means that they're all 60 degrees. And so all three of those would be equal, so they'd have to be 60 degrees. Okay, so sides, we have scalene, isosceles, and equilateral. And angles, we have acute, right, obtuse, and equiangular. Okay, so we already know that all of the angles added up together in a triangle equal 180 degrees. But what we are going to talk about now is the exterior angle theorem that would look something like this. Actually, I don't want that triangle. I want something that looks a little bit different. Let's do an obtuse one. There we go. And I'm going to extend this. And I'm going to label these as 1, 2. I don't want to do that. I don't like those. You'll see why here in a minute. I'm going to label these as X, Y, and Z. Okay. So, in the exterior angles theorem, Z is equal to X plus Y. Okay, so Z would be connected to this angle. Obviously, it's supplementary with that angle, but Z is actually equal to X plus Y. So let's get an example of something like this and what it might look like. So I'm going to pull this from underneath example 4, number 3 under monitoring progress. I'm going to put that one together to the best of my ability. Okay, looks pretty similar to that. I think I did, whoop, I don't want red. Pretty similar to that. Did a pretty decent job. So I've got 40 and 3x, and then it gives us the exterior angle is 5x minus 10. So we're going to solve for x, and we're going to find all the angles, just for funsies. So here's A, there's B, and C. Okay, so the exterior angle, 5x minus 10, is equal to the sum of the two opposite interior angles, and that's going to be 3x plus 40. So now we just use some algebra here. We're going to subtract 3x. I'm going to go ahead and include this in one step. So that's going to give me 2x equals 50. Divide both sides by 2. X equals 25. So now we could find all of the missing angles. 3 times 25, that's going to be 75. Okay, 5 times 25 is going to be 125, minus 10 is going to be 115. These two are supplementary, so we would know that this one is 65. And then 65 plus 40 is 105. 105 plus 75 is 180. So all of those work out. So angle A is 40. Angle B is 75. I got to label these with 3 letters. So I'm going to go angle BCA. That's the interior angle. That's going to be 65 degrees. Well, degrees on all those, sorry. And then my exterior angle, I better put another letter there. That's going to be angle BCD, and that's equal to 115 degrees. So exterior angle theorem, we take the exterior angle and we set it equal to the two opposite interior angles of the triangle and solve. Little lengthy today, 12.5 minutes, lots of material. That is chapter 5, section 1, angles of triangles.